3 minus 3. So here 3 minus 3, this is the transpose of A plus B, and which is our first result. So note this result, which is our left hand side, which is transpose of A plus B, is equal to 6 3 4 minus 3. Now we will get the right hand side, which is transpose of A plus transpose of B, and we will prove that equation number 1 is equal to equation number 2. So let us look at our right hand side. So here A is equal to, we will need to find transpose of A first. So we have A is 2 3 1 0. So our transpose of A is equal to 2 and 3 in first column and 1 and 0 in the second column. In the same way, transpose of B is equal to, we will get 4 1 and 2 minus 3. So our right hand side is equal to transpose of A plus transpose of B, which is equal to 2 1 3 0 with the addition of 4 2 1 minus 3. And by adding these two matrices, we will get 4 plus 2 is equal to 6 3 4 and minus 3. If you look at your first result, which is the transpose of A plus B, which is also equal to 6 3 4 minus 3, this one is our right hand side and result number 2. So from 1 and 2, we have proved that transpose of A plus B is equal to transpose of A plus transpose of B. So this is also most important method of example, because normally there is 2 or 3 kinds of example which are usually asked in GTU exam related to addition and subtraction. So first it may be the direct addition with the scalar multiplication of the matrices, which we have discussed in the first example, and the second type of example is addition and subtraction example, but with the use of transpose matrices. So we have discussed this both kind of example here. Now if we look at the PPT, our next topic is the matrix multiplication. But before we go to the matrix multiplication, just discuss one more topic, which is the null matrix, or we can say zero matrix. The matrix M cross N is zero matrix, denoted as 0 if the M cross N matrix whose all elements are 0. If in the matrix A, if all elements are 0, then the matrix A is called null matrix, or we can say it a zero matrix and denoted by big 0. Okay, this is the example of 2 cross 2 null matrix. This is 1 cross 3, and these are some properties that if we add any matrix with the null matrix is equal to A minus A is equal to 0, and 0 into A is equal to 0. Now our next topic is to multiply matrix A and matrix B. This is the multiplication of two matrices A and B. So first we need to discuss then when we can multiply two matrices A and B, if it is possible to multiply any two matrices A and B or not. So answer is no, we cannot multiply any matrices, but we can multiply two matrices for which in the first matrix the number of columns must be equal to number of rows in the second matrix. Let us look at the PPT. Then if the matrix A has the dimension M cross N and the matrix B has a dimension N cross B, then and then we can multiply these two matrices A and B, because here the number of column in first matrix is N and the number of rows in the second matrix is also N. So we can multiply these matrices. and if we can multiply these two matrices, then what will be the dimension of the resultant matrix. So if the matrix A has the m rows and if the matrix B has p columns, then the resultant matrix have m rows and p columns. So in the result, if we multiply A and B, then the dimension of AB is m cross p. Okay, so this is the basic things about the multiplication of two matrices. If the number of columns of A does not equal to number of rows of matrix B, then product AB is undefined. That means we cannot find AB if n here number of columns in A and number of rows in matrix B is not equal to each other. So now just go deep in the multiplication of, if we can multiply two matrices, then how to multiply two matrices, because multiplication of matrices is not as usual as the addition of two matrices. So just we need to concentrate on the method how to multiply two matrices. Okay, here we have two matrices 3 minus 2 1, 0 4 minus 1 and 2 4 minus 1 3 minus 3 1, and we want to multiply A with B. And first we multiply across the first row and down the first column. That means we will multiply the first column elements of matrix A with the first row elements of the matrix A with the first column of the matrix B, and the corresponding element. That means first element of first row with the first element of first column, then second element of first row with the second element of first column, in this way. Okay, so we will multiply 3 with 2, which is equal to 6. Then we will put the plus sign, and then minus 2 is the second element of first row with the second element of first column. Minus 2 into minus 1, which is equal to plus 2. Then 1 with minus 3. So this is the first element of the matrix multiplication of A and B, which is equal to AB, and this is the element of first row and first column, which is 5. So after this kind of calculation, we can multiply A and B in this way. First element we have already defined, we have already calculated that first element is 5. In the same way, now if we multiply across the first row and down the second column, so we have already multiplied first row with the first column of matrix B. Now we are going to multiply first row with down the second column of matrix B. So now we will multiply 3 with 4, then minus 2 with 3, and then 1 with 1, so which is equal to 7. So our second element of first row of AB is 7. Okay, then now we will going to change the row in matrix A, and now we multiply the second row with first down the column, then second row with second down the column. Okay, so now we will multiply 0 with 2, then 4 with minus 1, and then minus 1 with minus 3. So we will get minus 1. So first element of second row is minus 1. In the same way, if we multiply 0 with 4, then 4 with 3, then minus 1 with 1, so we will get 11. So this is the second element of second row, which is 11. So in this way we can multiply these two matrices A and B, and just we need to practice of the multiplication of matrices, otherwise it's tough to remember the method of multiplication. And notice that the size of A and B, here A is 2 by 3 and B is 3 by 2, and the matrix is AB is 2 by 2. Okay, here we have first multiply A with B. Now I am going to multiply B with A to prove you that matrix multiplication is not commutative. That means A into B is not equal to B into A. So we're just going to prove that AB is not equal to BA. So if we multiply the matrix B with A in the same way, because here there is 2 columns in matrix B and there is 2 rows in matrix A, so we can multiply B with A. Okay, I have shown that 2 is equal to 2, we can multiply. Okay, and the size of answer I have mentioned here that the size of answer is 3 cross 3. So from here we can say that AB is not equal to BA, because answer of AB is 2 cross 2, and here we will get size of matrix is 3 cross 3. So size is not equal, so we cannot say that AB is equal to BA. And the answer BA of 6 then 12, I have shown the multiplication and the calculation is also here. So then 2 4 with 1 1 is 2 into 2 what, then 4 into minus 1 is minus 2. In the same way, if we multiply second row with first column, second row with second column, third row with third column, and we will get the second row of BA. In the same way, so this is the answer of BA, and which is not equal to AB. So completely different from AB. So be aware that AB is not equal to BA. This is the most important result, that AB is not equal to BA for every matrix A and B. That is possible that in some matrices it is possible that AB is equal to BA, but generally we cannot say that AB is equal to BA. Okay, now look at some example which asked in GTU exams related to multiplication of matrix. Let us look at one example. The question is so that A is equal to 3 1 minus 1 2 is solution of S square minus 5a plus 7i is equal to null matrix, which is equal to 0. We need to prove that this matrix A is solution of this matrix equation. So first we need to find A square. Here we have A is given, so A square is equal to A into A. So we will multiply A with A, 3 minus 1 minus 1 2, with the same matrix 3 1 minus 1 2. So here we will multiply first 3 with 3, then 1 with minus 1. So 3 into 3 is equal to 9, then 1 into minus 1 is equal to minus 1. In the same way, then we multiply 3 with 1, which is equal to 3, then 1 into 2 is equal to 2. Then we will change the row, we will concentrate on the second row and multiply in the same way. Minus 1 with 3 is equal to minus 3, then 2 into minus 1 is equal to minus 2. Okay, then minus 1 into 1 is equal to minus 1, and 2 into 2 is equal to 4. So after all, we will get the multiplication of this a into a, which is a square, is equal to 8, 5, minus 5 and 3. This is our a square, and we need to find a square minus 5a, which is the scalar multiplication of a with 5 plus 7i. So now a square minus 5a plus 7i is equal to, we have already find a square, which is 8, 5, minus 5, 3, minus 5a. So 5 into a is equal to 3, 1, minus 1, 2, plus 7i. I is the identity matrix of 2 by 2 size. So it is 1, 0 and 0, 1. So here equal to 8, 5, minus 5, 3, as it is, minus 5 into 3, which is 15, 5, minus 5 and 5 to the 10. So this is the scalar multiplier. Then 7, 0, 0, 7. Then after the addition and subtraction of these three matrices, we will get here 8 minus 15 plus 7, here 8 minus 15 plus 7. Then in the same way 5 minus 5 plus 0, then minus 5 minus minus 5, so minus minus plus 5 plus 0, then 3 minus 10 plus 7. So after the calculation, we will get this is 0, this is 5 minus 5, 0, this is also equal to 0, and this is 0. So this is the null matrix, which is equal to 0. This one is our left hand side and this is our right hand side. Okay, so we have proved that a square minus 5a plus 7i is equal to 0. This example was asked in July 2000